Imagine a human heart. When a blood vessel gets blocked, surgeons insert a tiny metal tube called a stent to keep it open. If this stent is even a fraction of a millimeter too big, it could tear the artery. If it is too small, it slips right out of place. How do engineers measure something so small with absolute life-saving precision? They use an instrument called a Vernier Caliper. Today we are going to master this device, learn how to read its scales and solve a high-yield NEET question in seconds. Let's dive in. Vernier Caliper is a highly precise instrument used to measure length, depth and internal or external diameters. Let's look at its parts on a simulation. It has two main jaws at the bottom to measure the outside of an object, like a stent or a steel bowl. The two smaller jaws on top measure the inside of an object, like a hollow pipe. And that thin metal strip popping out the back, that is the depth probe. According to NCERT principles, the precision of a measuring instrument depends on its least count. The least count is simply the smallest value the device can accurately measure. For a Vernier caliper, the least count is the difference between the length of one mean scale division and one Vernier scale division. Least count LC equal to 1 MSD minus 1 VSD. Usually, 10 divisions on the Vernier scale match exactly with 9 divisions on the main scale. When we place a solid sphere between the lower jaws, how do we take the reading? It is a simple two-step process. First, find the main scale reading. This is the mark on the fixed scale that lies just before the zero of the sliding scale. Second, find the Vernier scale reading. Carefully scan the sliding scale and find the one single line that perfectly matches up with any line on the main scale above it. Total reading equal to MSR plus VSR times LC. But watch out, sometimes when the jaws are completely closed with nothing inside, the zero of the Vernier scale does not perfectly line up with the zero of the main scale. This is called a zero error, and we have to subtract it from our final reading to get the true measurement. Let's now solve some practice questions on this topic, including some PYQs. Let us begin with a very simple question, which is, which of the following is not a part of a Vernier caliper? We know that main scale, Vernier scale and inside jaws is all a part of Vernier caliper. This is a part of screw gauge, so the correct option is ratchet. Next, this is a very simple question right here. What is the fundamental principle on which a Vernier caliper operates for accurate measurement? We know that least count of Vernier is MSD minus VSD. So we have to find an option which is given as this. So we see that the first option right here says that it measures the difference between one mean scale division and one Vernier scale division. So the correct option is option 1. In this calculative question, we have to find the Vernier constant, which is the least count. So first we have to write what is given. N plus 1 divisions of Vernier scale coincides with n divisions of main scale. This is easy. So this is n plus 1 divisions of VSD equals n divisions of main scale. Now they are asking us to find least count, which is equal to MSD minus VSD. We know that 1 MSD represents 0.1 millimeters, which is given as 1 MSD equals 0.1 millimeters. We have to convert this into centimeters because they are asking for the least count in centimeters. So 1 MSD equals 0.01 centimeters. We find VSD by taking n plus 1 to the right hand side, n times MSD divided by n plus 1. Now that we found VSD, we put it into the least count formula. LC equals MSD minus n times MSD divided by n plus 1. Next we take MSD common, which gives us MSD times the quantity 1 minus n divided by n plus 1. Now we take the LCM of this, leading to MSD times the quantity n plus 1 minus n all divided by n plus 1. The next step is to put the value of MSD as 0.01. The plus n and minus n cancel out, leaving us with 0.01 times 1 over n plus 1. This 0.01 changes to 1 over 100. Therefore, 1 over 100 times n plus 1 is our final answer, which is option 2. Now we have a very simple question right here, which is the least count of a Vernier caliper represents the maximum length that can be measured by the instrument, the total number of divisions present on the Vernier scale, the smallest accurate measurement that can be obtained using the instrument, or the permissible range of experimental error in any measurement. Now, we already know that the least count of a Vernier caliper represents the smallest accurate measurement that can be obtained using the instrument. So, the answer for this question is option 3. If you found this visual breakdown helpful, you need to put that knowledge to the test right now. Head over to neetapp.in or download the NEET app today. We have chapter-wise, concept-wise and level-wise MCQs from easy to moderate to hard waiting for you to master. Plus, you can take free full syllabus mock tests, grab premium NCERT aligned study materials and enroll in our ultimate NEET crash course to supercharge your prep. Don't just watch physics, conquer it. Hit that subscribe button, click the link in the description and I'll see you in the next video.